Hello, this question is about the application of projectile motion in basketball. So I am going to show you how to solve this type of problem. Let's get started. A basketball player shoots toward a basket 6.1 meters away and 3.0 meters above the floor. If the ball is released 1.8 meters above the floor at an angle of 60 degrees above the horizontal, what must the initial speed be if it were to go through the baskets? This is the diagram for the question. So here we have the height at which the ball was projected or was shot 1.8 meters above the floor. And this is the angle of projection, 60 degrees. So the ball would move from this point of projection and travel to get into this basket. This is another new height, which is 3.0 meters. And then the horizontal distance or range covered is given as 6.1 meters. So 1.8 meters, the ball was projected from this height. So we can call this initial height H1, and here we have final height H2. You can see that the ball will move from this height to this new height if it were going to go through the basket. So there is a change in height, and we are going to find that first. So we say H2 minus H1, which is 3.0 minus 1.8, and that is going to be 1.2 meters. So we are going to be working with this change in height. The second thing that we need to consider is the time it would take that ball from this point of projection to travel and enter inside this basket. That's time. We need to find that time first. And to do that, we are going to apply this equation. Remember that the range can be calculated by using this formula, R equal to U cos theta times time. So from this formula, we can find the time it will take the ball to move from this point to this new heights. To do that, we are going to plug in what we have. The range is 6.1 meters, 6.1 equal to U, we are looking for it. Cos theta is 60 degrees, then multiply by time. So here we are having 6.1 equal to, so we can say UT in this case, cos 60 degrees is 1 over 2 half. Now we need to cross multiply 2 times 6.1, we are going to have 12.2 equal to UT. We are looking for the value of T, so we're going to make T subject of the equation. Therefore, 12.2 divided by U will be the time it will take for the ball to move from this point to this point. Okay, so we are going to be working with this time. Let's take notes. The second thing that we need to find now is the initial velocity. Okay, and to find the initial velocity, we are going to use one of the kinematic equations, precisely the second equation. So we have this equation as S equal to UT plus 1 over 2 AT squared. Okay. Now, this S is the distance, but we are dealing with height. So we are going to replace S with height. Change in height equal to velocity along the y components, which is this, times t. Acceleration of free fall is negative in this case. So definitely this plus will change to minus 1 over 2. A is becoming g, and then we have t squared. So we are going to be working with this equation. So let's quickly transfer it to this point. So we're having this equal to u times t minus 1 over 2, and then gt squared. So let's plug in what we have. Change in height is 1.2. So we are going to that 1.2 equal to u, that is the velocity along the y component, this value. Remember that velocity along the y component is given as this equal to u sine theta. So instead of using this, we are going to replace this value with this in this equation now. So we are going to say u sine theta, which is 60 sine 60 degree, times time taken. Remember, we found the time to be 12.2 divided by u, then minus 1/2 times the value of g, which is 10, times the time again, t squared. Again, we write 12.2 over u, everything is squared. So because of this squared, so we have 1.2 equal to u. There is u here and there is another u here. So this u can cancel out this u. Sine 60 degree is 0.8660 times 12.2 minus 1/2. These two can cancel out this 10 5 times. And then we are going to have 5 times 12.2 squared. So 12.2 squared is 148.84 over u will become u squared as well. We have 1.2 equal to 0.8660 times 12.2. The calculator gives 10.57 approximately, and then minus 5 times 148.84. So we are having 744.20 divided by this u squared. So now we need to collect the like terms, or moving this value, because it's with the u that we are looking for, to the left hand side, and then this 1.2 comes to the right hand side. And if that happens, so this becomes 744.20, the negative sign is gone, over u squared equal to 10.57. This is coming here now, it becomes minus 1.2. So we have 744.20 over u squared equal to 10.57 minus 1.2. So this will amount to 9.37. If you look at this equation, so we are going to say cross multiply, right? U squared times this, and this is like over 1, but there is no need to write that. So we are just going to write our u squared here equal to 744.20. This is just simple arithmetic, divided by this 9.37. Now 744.20 divided by 9.37, what do we have? U squared equal to 79.42. Now we are looking for the value of u, not u squared. So we need to take the square root of both sides. And if we do that, we are putting square roots here, and then we are putting square roots here. So this cancels out this. We are left with only u. So the square root of 79.42, the calculator gives 8.91. So but to one decimal place, we are going to write our answer as 8.9 meter per second. So this is the initial velocity that is required to shoot the basketball from this height, to travel to this height and then enter inside this hoop. This is how to solve this type of problem. Thank you for taking your time to watch this video. Please do like it and share it with more students. If you are not yet a follower of this page, endeavor to do so for more updates. Goodbye.